Jo, das ist jetzt eine recht überschauliche Runde. Von dem her können wir das Ganze... is there anybody who doesn't speak German in here? You speak English?
Yeah, sorry.
Okay, so then we will do it in English as planned. What I would like to talk about, well, first I will introduce myself. My name is Alex List. I'm originally from Austria. I lived in the beautiful city of Graz for 15 years, studied there, and started working with the people of Funkfeuer, who built up a wireless community network, very similar to what you know as Freifunk in Germany, or Gifinet in Spain, or AMVN in Athens. And about 2 years ago, I moved to Zurich, and there is a community network called Open Wireless, but basically I found 1 or 2 nodes in the node database, so I considered the network as non-existent, and my motivation to bootstrap a community network in a very wealthy country like Switzerland, well, there was no motivation anymore. So I decided I need to do something useful with my spare time. And of course, you could play around, hack, build up your wireless node on your rooftop as an island, but I considered that rather boring. So I thought, okay, what are the common goals and problems of community networks? And well, community networks in Austria, for example, are more like experimental networks for geeks that want to try out new technologies like mesh routing protocols, like building homebrew antennas from cans, whiskey cans or whatever, or some potato chip cans. And we have one common problem, and that is we need more spectrum. If we want to bring people to the net or create our own independent network, we need radio spectrum. Now, where does radio spectrum come from? We're talking about electromagnetic waves. Electromagnetic waves are just there. They have existed before man. They will exist after us. And basically they're owned by nobody, like the air that we breathe here. Now, there were some well-known inventors like Marconi or Heinrich Hertz who have discovered the physical features of electromagnetic waves, that they can travel even around the globe or to other galaxies, depending on the frequency. And I think it was in the early 20th century that it was discovered radio could also be a medium to transport information. Now, in the early 20s, in particular in the United States, there were broadcasters just randomly using frequencies, and you all know what happens when 2 people use the same frequency at the same time. You just hear some disturbance, right? It's like 2 people who use a walkie-talkie at the same time on the same frequency. A third party won't be able to understand either of the 2. That's when governments felt obliged to start regulating radio spectrum, because broadcasters would just try to jam each other out of the channel, one building a more powerful transmitter than the other one. And like in road traffic, politicians deemed it necessary to introduce some rules who can use which part of the radio spectrum at which particular time. Now, this dates back to the earliest 20th century. If you talk about radio stations in the 20s, we're talking about huge tubes and huge amplifiers, and if you wanted to change the frequency, you even had to change parts of the antenna, because the antenna was suited for exactly one frequency. So it wasn't as easy to change a frequency as you now do on your TV set, or even here on a laptop on Wi-Fi, where you can just choose a channel, because everything now is digital. It was a huge effort to change frequencies. So the rule was, okay, you can use this frequency exclusively in this particular region, maybe also depending on the time. And let's jump now to 2010. We have digital signal processing. We have computers that are far more powerful than anything you could imagine even 10 years ago. And even in every mobile phone, the computers are more powerful than ever. And one significant advantage now is you can listen before you talk. But still, the radio regulation dates back to the 1920s. The whole system of radio regulation is based on the assumption that only one user can use a particular frequency at a given time in a given region. Nothing has changed about that, but technology has changed rapidly. I would like to show you some of the bureaucracy around radio regulation. This is a web page made by Bob Horwitz, an American who lives in Prague for years already and who has been active in radio spectrum policy for years. On top of all, you have the International Telecommunications Union. That's a sub-organization of the United Nations, like the World Health Organization or the Atomic Energy Organization. And that's where global rules about radio spectrum are made. There is the ITU-R, the radio communication sector of the ITU, and the members of the ITU are states, national states, member states, like Germany, Austria, and they all have their delegates. Sometimes you find members of industry, like manufacturers or network operators, who are sent by member states as part of the national delegation. But by itself, ITU is a quite closed club. It's quite pricey to get in. It's really hard to be accepted as an NGO compared to other UN fora where they talk about human rights. It's a quite exclusive club. And if you want to have access to ITU standards, for example, you have to pay to get them. It's not like in the internet where you can go to ietf.org and download requests for comments that are basically defining internet standards. This dates back to, let's say, the whole spirit of the 20th century, where you had those national postal administrations and you were not allowed to use a modem that was not officially type approved by the Bundespost or whoever, or the FCC. So the whole radio telecommunication sector was strongly regulated. Apart from the ITU, there are regional conferences or organizations of regulation authorities or government administrations. For example, in Europe, there is the CEPT. That's French for Conférence Européenne des Postes et Télécommunications. French always was a diplomatic language. It has lately been superseded by English, but yeah, that's basically the European level of cooperation of those administrations. And also the different regions of the world are separated by ITU, because most radio waves, except maybe for shortwave, don't travel very far. Shortwave can be reflected by the ionosphere, so that travels around the globe. But if you're talking about UHF or VHF or even wireless LAN, those frequencies don't travel very far. You can notice that yourself. After a few hundred meters, it's over. So there are different frequency allocations in different regions. And well, I said waves don't travel very far. That's only true to a limited extent. If you're talking about VHF frequencies, so let's say 100 megahertz to 300 megahertz, or UHF, that's maybe 400 to 900 megahertz. That's where usually the TV frequencies are at home. They do travel quite far, let's say maybe 70 kilometers, depending on the altitude of the transmitter. And If you look at the map of Europe, you have a lot of countries with lots of bordering states. And of course, there you need some kind of cooperation between the different governments so that there is no interference. Okay, I'll go back to my presentation. This was just a quick overview of who is doing what here. Interestingly enough, the CEPT is also, it consists of member states, but it is far more open to members from academia, to companies, and also to NGOs. And in particular, if you have something substantial to say on a technical level, my experience is that you're openly welcomed to join the fora of CEPT. And that's what we did since last December. So about a year ago, I decided with some friends to start an organization called Open Spectrum Alliance. Sorry. With these goals here. We tried to unite community wireless networks, manufacturers, wireless ISPs, to create an independent lobby organization for more open spectrum. Open versus closed. Open means we want more spectrum to be available for everybody's use, like you have it with Wi-Fi, like you have it with Bluetooth. But these technologies currently work in a very limited set of bands. For example, Wi-Fi is only available on 2.4 gigahertz and 5 gigahertz. These frequencies were considered the junk band. Why junk band? Because microwave ovens are there, industrial applications are there, so there was just interference in this band. And well, it was exactly 25 years ago today that the American administration that's responsible for radio, the FCC, the Federal Communications Decision, decided to allow unlicensed use of this 2.4 gigahertz band with spread spectrum technology. Now, why was that important? It was changing the whole idea of how spectrum could be used. Because so far, we had an assumption of scarcity of radio spectrum. That's why there was the rule that you can only use a particular frequency exclusively. You're assigned a frequency, you're allowed to use it, nobody else is allowed to use it. Eventually, you have to pay the government some fee to use it. You might have read the news about Germany. Some mobile operators participated in a nice auction, and the German finance minister just made 4 billion euros. I always ask myself, for something that's actually free and belongs to everybody, now we have the state making 4 billion euros, and we have some companies basically asking you to pay some toll to use those radio waves. The politics are still back in the 20th century, but the FCC decision 25 years ago was groundbreaking, because if you use spread spectrum, what you do is you allow multiple users to use the same frequency at the same time. Or let's say you could also consider time division multiple access, where you have time slots, like in Aloha protocol or in other wireless protocols, shared use of the spectrum. This is new because these technologies are now, like Aloha, 40 years old. And 25 years ago, the FCC allowed the junk band to be used with these technologies. But if we consider that there is far more spectrum available, I will show you something about the UHF spectrum. We're talking about terrestrial television. You might have noticed that using your old analog TV, you cannot get the signal anymore in most parts of Europe because everything was switched over to DVB-T, digital television, terrestrial television. And okay, I mean, in Germany, these numbers are 3-4 years old, so one has to be careful. This might be already a higher number now. About 5%, let's say maybe 10% of the population use terrestrial television. The rest uses satellite, cable, and more people use IPTV to receive their TV signals. So we have 490 to 862 megahertz, or now there was an auction, it's only 400. Let's say we have 350 megahertz of spectrum in the UHF band that's used for television, for 5 to 10% of the population. Do you think it is justified to reserve such a huge part of the spectrum just to distribute television? Everybody who can receive terrestrial television usually could also put up a satellite dish and have a far bigger selection of TV channels, even free to the air. They don't have to pay for it. This is true for Germany. This might also be true for Austria, where we have a similar situation. You see the blue bar is in the range of 5 to 10%. But if you have ever been to Rome or to Madrid and you look on the rooftops, you see a forest of antennas. So in Italy, there is basically no cable television. Satellite television is almost also non-existent. So people rely on terrestrial television. And that's the difficulty here. If you apply the ideas of wireless LAN, of sharing spectrum, to the UHF frequencies, you could just listen. Is there a TV transmitter station on a particular channel? If no, why can't we use it to create a mesh network? Or why can't we use it like we have wireless access points? As long as your power level is low and there is no primary user like a TV station, why couldn't you use this frequency? Well, the FCC in the US made another groundbreaking decision. They are allowing the so-called TV white spaces to be used for data communications. TV white spaces are TV channels that are unused in a particular region at a particular time. Well, usually the position and the time of use of a TV frequency or a transmitter doesn't change. These things are usually on mountaintops and they don't move around. So you know the position, you know the frequency, and usually they transmit 24/7. So they're not switched off usually. And if you look at how many channels there are, I think it was something like 69 channels on your old analog TV set, maybe 1/3 is used. The rest is unused, or the signal comes from so far away that it's unusable. So if you just transmit with maybe 100 milliwatts, you won't disturb anybody, but you can use those frequencies. And why is this important? UHF can penetrate buildings. That's why you can receive television even indoors with a small antenna. And it travels quite far if you put the transmitter high enough. The problem we have in Europe is this big difference between countries like Italy and Spain and others. If you go here to the right, there is almost no terrestrial television at all. So a one-fits-it-all approach for Europe won't work. What's happening right now is that the technical details of how spectrum can be shared in Europe are discussed in a working group of CEPT called Spectrum Engineering 43, and there you find all the usual suspects. You have mobile operators, you have broadcasters like the BBC, or media broadcast from Germany who are doing services for private TV stations, mostly private stations, and they're fighting about levels, protection levels. Okay, when do you consider a particular channel as free, or how many free channels are there at all? It's the usual suspects discussing there, and I just registered to participate in that working group and went to Geneva the first time, I think, in December. And fortunately, we have quite some quite good native English speakers in our membership in Open Spectrum Alliance. So we presented a substantial paper about rethinking the whole idea of using radio spectrum. And it was openly received because it was technically sound. We presented good arguments, and some of our points even ended up in the summary document of this workshop. I mean, it's ongoing work. It might still be a bit watered down, so you have to go there regularly. But as a matter of fact, if you want to get involved, if you have something substantial to say, those people are all engineers, and engineers are usually open to arguments of other engineers. So that's one surprising experience I made. You're not considered an enemy as long as you have something substantial to say. You're welcome. I mean, we were even fighting with people from Italy representing Mediaset, which is Mr. Berlusconi's media imperium. And of course, they maybe have another position on the subject, but as long as you can provide convincing arguments, you can still have a civilized discussion and maybe find a compromise. And I think that's where we have to go. We have to find a compromise that doesn't prevent countries that want to open up the TV band to other users than TV, and countries like Italy, where basically almost everything is occupied. But even inside Italy, you have regions like Piemonte, where not everything is occupied by television, but also there is no broadband rollout that covers 100% of the population. So even in countries like Italy, you have small, let's say, opposition against this media industry that wants to capture the entire radio spectrum. And so there is some hope also in countries where the media industry has a lot to say. I would like to go back to the founders of Open Spectrum Alliance. We met something like a year ago in Vienna, and if you were active in Freifunk or so and community wireless networks, you might recognize some names. It's not the names that are important, but it's their background and their histories. If you look at Aaron Kaplan, founder of Funkfeuer Vienna, Armin Medosch, writing books about wireless communities for years. Georg Erber, he's an economist writing for the German Institute of Economics in Berlin. He has written dozens of papers about common spectrum, about auctions, if it's right to do auctions, how to solve the problem of the digital divide, how to cover rural areas. So there are people who actually speak up and publish on an academic level. Joseph Bonicioli, Athens Metropolitan Wireless Network. They have something like 5,000 nodes. Jürgen Neumann, Freifunk. Malcolm Madsen was one of the founders of, or was the founder of Colt Networks, nowadays a large carrier in Europe. Michael Habeler started the first commercial ISP in Austria in 1991. Ramon Roca, another guy from our community network, Gifinet, around Barcelona. They have now 12,000 nodes in an area where there is basically no commercial broadband service available, or it's just not affordable for the population. Then Bob Horwitz, who has been doing research and publications on open spectrum issues for decades already. Yeah, we have Sasha Meinrad from the New America Foundation. He started basically CUWIN, a university campus wireless network in the States, and is now one of the, well, how should I say, most prominent spectrum, open spectrum advocates in the United States. He's working for a think tank called New America Foundation. Tano Bayankin, who studied law, is helping us with legal stuff like getting an association registered and this kind of stuff. And some name nobody will recognize, but I think he's particularly important if we consider today's historic day. 25 years of the FCC rules that allow Wi-Fi. Vic Hayes. Vic Hayes is a Dutchman. He was working for NCR, a company that produced cash registers. And his employer asked him, we have this nice flagship store, everything with marble. We have the cash registers, have different cash desks. We cannot put Cat5 cable there or coax cable to network those cash registers. We need something wireless. Please go to the IEEE and please define some wireless standard. And that's what he did. He was the first chairman of the IEEE 802.11 working group, and they were desperately looking for spectrum. So they discovered, hey, there is the 2.4 gigahertz junk band. Let's go to the FCC and ask them if we can use it. And 25 years ago, FCC said yes. So Vic Hayes is considered by some the father of Wi-Fi. He's now working as, I think, research associate at the Technical University of Delft in the Netherlands. And he's now finalizing a book about the history of Wi-Fi. So he was one of the key figures making all this Wi-Fi revolution possible. Yeah, and then we have Xavier Carcel, who is also active in open hardware, which is also a very important topic for wireless networks. Over time, more members joined us. These are the individual members. Some of them from community networks, some are academics doing research on spectrum sharing on cognitive radios. But also, for example, Brett Tarnitzer and Karen Rege from a company that's basically dealing with how to efficiently do spectrum auctioning. So there's quite some interesting membership now already. Maybe also one of you in the very near future. There are no membership fees. We just ask people to give us some input and cooperate. Interestingly enough, so we have those community networks like Gifinet from the Barcelona area, Funkfeuer from Vienna, Freifunk, Athens Wireless Metropolitan Network, but we also have Skype. They're also interested in more open spectrum. And it's not a secret, there are also other companies fighting for more unlicensed spectrum. Google, Microsoft, they might be considered evil in other contexts, but especially when it comes to spectrum, they're all on the same page. They want more free spectrum, not completely unregulated, but without paying expensive license fees, without having a need to register with the national authority. Just like Wi-Fi, you can use it everywhere. It's just almost everywhere. In almost all civilized countries, Wi-Fi is legal. It's usually dictatorships that don't like this kind of networking stuff at all. Yeah, and then we have the New America Foundation, and well, you might know Mr. Soros from the financial markets. There is also the Open Society Institutes that supports different initiatives, and they also supported our first meeting. We will see if this will continue with our future work. And what we did in the last year, we looked at all the EU bureaucracy, because in Europe, a lot of spectrum policy is not done in the CPT. The CPT mostly defines technical standards, how to do something. What is done is decided in EU directives or in national laws. So you have to get involved in EU policy if you want to influence spectrum policy in Europe. There is the executive branch of the European institutions, that's the Commission. And the good thing about the Commission is, before they decide something, they usually do public consultation, where everybody is invited to submit a statement. And again, if you have something substantial to say, if you provide good arguments, your arguments might end up in the summary document. There is also the possibility to directly approach members of the European Parliament, MEPs. These are usually not technical people, they're politicians. You can think about politicians what you want from your own experiences. My experience was they're quite open to know-how. So if you can provide them an independent view compared to all the paid lobbyists who approach them every day, they're quite open to an independent viewpoint that, for example, an NGO can provide. Because to my knowledge, there is no NGO that does spectrum policy in Europe. There might be others for civil liberties in the digital era, like La Quadrature du Net and similar organizations, but nobody is focusing on radio spectrum policy. What else do? We participate in conferences, like the EU Spectrum Summit, end of March in Brussels, where again the usual suspects from lobbyists, from the media industry, from the telecoms, members of the parliament, members of the commission, or officials of the commission, discussed about spectrum policy. This was again an open event. Everybody who registers and has something substantial to say can go there and actually do that. So also in other policy areas, if you have something to say, I encourage you, please go to Brussels and do it. Nobody will stop you from doing that, except maybe the money required to travel to Brussels and accommodation. But I mean, there is couch surfing, right? So that's not a reason not to do it. Yeah, we had some media work. So suddenly people from the public broadcasters started to approach us. So we gave some interviews and provided them with some input, in particular around the discussion on the digital dividend. We participate in the standardization work for white spaces, and also we try to facilitate knowledge sharing between different members, like in particular the community networks. You might have noticed that the German Bundesgerichtshof has recently decided about the legality of operating your own access point at home and how secure it has to be. Now, this is a very difficult discussion, because if you extend that to the hotel next door, I could get an internet access code without providing my ID details, and I could abuse it for anything I want. You can maybe go to the next coffee that provides free Wi-Fi even without the password. So, and this is obvious of substantial benefit to society that you have free Wi-Fi. Now, this is just being questioned by courts, and why it's being questioned? Yeah, well, it's the usual suspects from the media industry that want to go after file sharers. But I think this has to be a political decision. What's more important for society? Having internet access everywhere, or protecting the interests of an industry? I don't want to argue in a particular direction. This is a political decision, but I think one should carefully study the economic benefits of having free Wi-Fi access versus the interests of just one industry lobby. So these are the topics that we currently operate on. We're talking about the digital dividend. Unfortunately, this discussion is almost over, at least in Germany. It has been decided that parts of the TV spectrum goes to mobile operators. We're talking about 790 to 862 megahertz. And after Germany has decided to go this way, I think other European countries don't have a chance but to follow, because you want to have interoperable handsets, you want to have devices that work all over Europe. So this is the direction also on EU level that we are going to see. But there is still hope for TV white spaces, because there is no final decision about TV white spaces. Currently, CEPT is assessing the technical feasibility of using TV channels that are unused. And we're still missing a political decision on allowing this all over Europe. Yeah, and then just recently mentioned how legal is it to operate a Wi-Fi hotspot. I mean, Wi-Fi hotspots have been around for, I don't know, 15 years almost. And now suddenly some industry tries to stop this. I think this can't be the way to go. So this was already mentioned. Why is it important to get involved in policy decisions? Well, you have the broadcasters, they have the lobbies, like the European Broadcasting Union. They also have access to politicians. I noticed several German members of the European Parliament who argued for leaving the digital dividend spectrum to the broadcasters because they provide diversity, cultural and political diversity. So broadcasters are well represented in the European Parliament by certain politicians. What those people underestimate is the function that the internet provides for cultural and political diversity, because there is nobody that can control what you say there. Unless you do something illegal, then maybe the police will go after you or you're prosecuted. But if you want to just publish your opinion and you're not doing anything extremist, you can do that without anybody censoring you or editing what you want to say. So I think that's something politicians still have to learn. A second point I mentioned already several times, both politicians and technical working groups are open to competent input. If you have something substantial to say, like, for example, that the whole way of assigning radio spectrum dates back to the early 20s and that technology has advanced and that there is no reason why spectrum couldn't be shared between different users, people are open to input. Third point, if we don't get involved in politics, well, then just others will decide, and not for us. They will most likely decide for others, for the interest of others. So it's very important to make your point, to make your statement, to represent the community and not just those industry lobbies that are there. And the fourth point, I think Wi-Fi was only the beginning of a revolution. There are billions of devices now out there with Wi-Fi. Even mobile phones nowadays. Every new mobile smartphone you buy has Wi-Fi included. You don't have to use the mobile operator's network. You can use a Wi-Fi hotspot if it's around, which is also a lot cheaper usually, if not for free. Now, imagine you have more than just 2.4 gigahertz. Imagine you have UHF frequencies available. You can really go to rural areas and connect population that would otherwise have no internet access at all, or at just unjustifiable cost by going via satellite, which is also slow. So it's important to ensure that there is something after Wi-Fi, that there is more spectrum made available, open spectrum for data communications, internet access, and also local networking. Why is it important? Because I mentioned if you don't get involved, others will speak and not maybe in your interest. There was a statement from an Italian representative in this CPT working group, and he just claimed there will be very little spectrum available as white space. If you don't go there and counter that argument, it will end up in the summary document. And it will be used as a basis for European policy. So if you have proof that there is spectrum available, for example, some friends from Italy did something like a war driving campaign, but they didn't scan for Wi-Fi channels, they scanned for TV channels and the signal levels of the TV channels and created a map. And they could just prove that, of course, even in Italy, there is white space, contrary to what this representative of the Italian government said in this CPT meeting. So it's important to go there and maybe correct some facts or correct some non-facts. Then some input from a discussion I had yesterday evening about the German insecure Wi-Fi access points. Well, why should it be illegal to operate an access point if there is a phone booth out there where you can call the police and post a bomb threat, right? Nobody is controlling who is accessing a phone booth. And nobody would hopefully claim that we need video surveillance in every phone booth to track you down for posting a bomb threat. How often does this happen? I mean, do you still have a legal right to anonymously use a phone booth? I hope so. Otherwise, we live in a police state. So this is an area, I think, where everybody in his, among his friends or maybe journalists, politicians, should get involved and make the point about why open and uncontrolled, or let's say insecure, oh my God, Wi-Fi access points should still have a right to exist. I mean, what is insecure? To some extent, everybody is responsible for the device he's using, he or she is using. I mean, you should do something to prevent that you're Trojanized, that you're abused by criminals. Of course, you shouldn't do anything illegal yourself, but come on, you should have the right to provide your hotspot if you're a cafe owner or if you're a hotel. And if you want to share the internet with your neighbor, you should also have that right. Not only the right to have an open access point, but also the right to share internet connectivity. And that's something where we really have to work on. And that's where everybody can get involved. So talk to your politicians, find out who your politicians are, find out who your members in the European Parliament are, and talk to them. So where are we going in the future? We have some international projects in mind, in particular continuing the development of mesh networking like the OLSR protocol. We definitely need to do some scientific work on the socioeconomic impact of community networks, because that's one argument to convince politicians. I just know from Spain, or from Catalonia, in the region of Barcelona where they have GIFInet, internet usage rates are higher than in regions where they don't have GIFInet. Well, of course, because there is no alternative, because either the national operator, Telefonica, has no DSL service in remote rural areas. There is also no mobile broadband, so if there is a community network, there is higher internet use, and in general, that is considered beneficial for the economy and for society, until proven otherwise. And one important next step will be to find more members who join Open Spectrum Alliance. We're thinking about municipal wireless networks like, for example, I know about Oulu in Finland, where they have something like 1,500 access points across the city, completely open network. You can just open your laptop or take your smartphone and connect to the internet without any login, nothing. And there are many of those networks across Europe, and I think we should try to get them on board. There are wireless ISPs, in particular in countries like Poland, where until recently there was also no decent wired broadband coverage. Also in Czech Republic, they have quite some wireless ISPs, so we try to get those on board as well. And of course, then there are the manufacturers of Wi-Fi equipment. So that's the next steps that we plan for the near future. As already mentioned, if you want, you can join us. We're open to any new members who bring new ideas. Maybe want to do something like lobby the local politicians. That's, I think, the most important thing, to convince politicians. Then we always need help with cognitive radio stuff. I think there is no open source implementation of white space sensing. That's something that's required to provide the technical infrastructure for white spaces. So if you're good at signal processing, or if you know somebody who is good at signal processing and maybe also knows how to work with new radio, you're most welcome. We would really be interested in doing more in this area. Or you can just do a white space measurement campaign. You take a spectrum analyzer and drive around connected maybe with a GPS receiver, and you make a map of your region and discover, okay, how many TV channels are actually in use. Yeah, so to close, I hope this presentation was not too boring and not too chaotic. I would like to say happy birthday to Wi-Fi, because since 25 years it's legally possible to operate Wi-Fi in 2.4 gigahertz. And I would like to thank the audience, and if you have any questions or comments, I'm open for discussion. Thank you.
What do you think the white space agenda, in what way will it travel? How do you think will it end up?
I'm not sure if I understood your question. How far it travels, or
what do you think is the result of discussion? Will it end up regulated, or do you really think it will be open?
If I knew the answer, I think I would take bets. Honestly, there is a huge lobby pro white spaces. Google, Microsoft, Dell, Intel. There's one disadvantage, especially if you want to influence European policy. They're all American. This is actually a problem. Okay, NCR, which became then Algeria and then Alcatel-Lucent, I think, yeah, is a mix. There's an international company, and the groundwork for Wi-Fi was laid in Holland, not in the States. But still, it's an IEEE standard, and Europe had its own standard called HyperLAN. Europeans always tried to make different standards. Now, people have realized it doesn't help to have standards that only work on one continent. That's why you have now smartphones that have 4 bands now, at least included. And industry and also regulators realized that it doesn't make sense to have 10 different standards. You need one standard that works worldwide. Then you have economies of scale to manufacture the chips. So they become very cheap and available to everybody. So yes, I think it will happen. I think white spaces will be there. But there is still the media industry, in particular the media industry, and to some extent also the telcos that want to block it. How? By defining ridiculously low, or high actually, interference protection levels. If you have a TV transmitter in a particular area, in America they know something like the so-called service contour. That's the designated service area of a particular transmitter station. And now the discussion that we have now is, how do you protect that incumbent user? How do you make sure that no radio or no TV receiver in that area has interference from white space devices? You can only do that with a certain probability, because if you have a misbehaving device next to a DVB-T receiver, there will be a problem. But of course, you should try to make sure that the interference does not happen. And this is possible by 2 ways. A, by sensing. The problem is, if you're indoors with your laptop or your smartphone, and for television you use a rooftop antenna outside, indoors you might not sense the TV transmitter. That's the so-called hidden node margin. You might not sense that there is actually a TV station transmitting on that channel. You start to transmit, and you can cause interference to that rooftop antenna, especially if you're on the border or already outside this service contour. So there is a proposal to not only use sensing until sensing becomes more reliable, because we're talking about sensing way below the noise floor, right? This is technically very challenging. So the second approach is to use geolocation. So you have an assumption that in a white space network, you have one access point that also has a wired connection to the internet, and maybe a dozen or several dozen clients. Like here we have an access point over there, and several clients. And this access point has to access a geolocation database operated by or on behalf of the National Radio Regulation Authority. It sends a question, and that question is, my position is X and Y, and it gets back a list of channels with allowed power limits. So these are the two approaches that are now being under discussion both in the States and in Europe. And I think it will be up to industry to provide prototypes of devices that reliably avoid interfering with primary users. And I think if this technical challenge has been solved, it will be very hard for politics to ignore the possibility of white spaces. There is still some work to do, and there is heavy opposition from the broadcasters, but I think working prototypes and working systems like the internet, like Wi-Fi, have always been more convincing than just paperwork. So I think it will happen, but maybe not tomorrow. Yeah. Other questions? No questions. You all agree? Do you think it's useful what we do? Okay, at least. Was the presentation too chaotic? No? Okay. Sorry for not always following the slides, but I know I'm a bit chatty, but it's hard to get all this work from 1.5 years into 15 slides. It's almost impossible. Okay, if there are no more questions, thank you very much, and maybe see you at one of the next events. Ah, yes, I forgot one thing that's important. August, I think 12 to 15, in Vienna, there is the summit of the International Summit of Community Wireless Networks. So if you're interested in community networks, that's definitely the event to attend. Okay. My ThinkPad decided to shut down. I think the website is wirelesssummit.org. But I will link it from the openspectrum.eu website. I forgot to mention that. It was on the start page. Our website is openspectrum.eu, so if you want to know more or get in touch, the website is openspectrum.eu. Thank you.